am in live. If anybody connect me, please connect. Daily, I discuss civil engineering execution activity, project and plan related. Today, discuss method of structural analysis. Method of structural analysis. Here is a clear structural explanation of the method of structural analysis suitable for civil engineering students, infrastructure engineer, and exam preparation. Method of structural analysis. Here is a clear structured explanation of the method of structural analysis suitable for civil engineering students, infrastructure engineers, and exam preparation. Method of structural analysis. Method of structural analysis. Structural analysis methods are broadly classified into two categories. Structural analysis methods are broadly classified into two categories. Number one, statistically determinate structures basic method. Number one, statistically determinate structures basic method used when the number of unknown reactions, number of equilibrium equation used when the number of unknown reaction equal to number of equilibrium equations. Method of joints, pin jointed trusses. Method of joints, pin jointed trusses used for trusses. Each joint is analyzed using fx equal to 0 and fy equal to 0. Used for trusses. Each joint is analyzed using fx 0 and fy 0. Assumed members carry only axial forces. Assumed members carry only axial forces. Method of section. Method of section cuts the truss to expose internal forces. Cuts the truss to expose internal forces faster than method of joint when only specific member forces are needed. Faster than method of joint when only specific member forces are needed. Equilibrium method, beams and frames. Equilibrium method, beams and frames. Use basic statics. M0, Fx0, Fy0. Suitable for simply supported or overhang beams with no extra redundancy. Equilibrium method, beams and frames. Use basic statics. M0, Fx0, Fy0. Suitable for simply supported or overhang beams with no extra redundancies. Number two, statistically indeterminate structure. Indeterminate structure. Advanced method. Statistically indeterminate structure. Advanced method. When redundancies exist, equilibrium alone is not sufficient. So we use compatibility, flexibility, or stiffness concepts. When redundancies exist. Equilibrium alone is not sufficient. So we use compatibility, flexibility, or stiffness concept. Force flexibility methods. Force flexibility methods. Unknown equal to redundant forces. Unknown equal to redundant forces. A constant deformation method. Consistent deformation method. A consistent deformation method. Remove redundancies, convert structures to determinate, apply compatibility, use redundant beams, frames, trusses. A consistent deformation method remove redundancies, redund, remove redundancies, convert structure to determinate, apply compatibility, use redundant beams, frames, trusses. B. Maxwell reciprocal theorem. Maxwell reciprocal theorem. C. Castigliono's theorem. Energy method. C. Casti, Castiglione theorem. Castiglione theorem. Energy method used to calculate deflections or redundant forces. Used to calculate deflections or redundant forces. D. Unit load method. Unit load method. Apply unit load to find deflection in the same direction. Apply unit load to find deflection in the same direction. Mostly for deflection calculation. Mostly for deflection calculation. Displacement stiffness method. Displacement stiffness method. Unknown equal to joint displacement. Unknown equal to joint displacement. A. Slope deflection method. Slope deflection method relates in moments with rotation and displacement. Relates end moments with rotation and displacement. Used for continuous beams and grid frames. Used for continuous beams and grid and rigid frames. Used for continuous beams and rigid frames. Good for manual calculation. Good for manual calculation. B. Moment distribution method. Hardy cross. Moment distribution method. Hardy cross. Literative hand method. Literative hand method. Members distribute and carry over moment until balanced. Members distribute and carry over moments until balanced. Very popular for teaching and exams. Very popular for teaching and exams. C. Matrix stiffness method. Finite elements basics. Matrix stiffness method. Finite element basics. Forms global stiffness matrix K. Forms global stiffness matrix K. Use computers for large structures. Use computers for large structures. Foundation of STAD, SAP 2000, ET, ETAPS, etc. Foundations of STAD, START, STAAD, START, STAAD, SAP 2000, SAP 2000, SAP 2000, SAP 2000, ETABS, etc. ETABS, etc. ETABS, ETABS, etc. Number three, modern computer-based method. Modern computer-based method. Finite Element Method, FEM. Finite Element Method, FEM. Divides structure into small elements. Divides structures into small elements used for frames, shells, plates, bridges, buildings, towers. Used for frames, shells, plates, bridges, building, towers. Accurate stress and deflection prediction. Accurate stress and deflection prediction. Finite difference method, FDM. Finite difference method, FDM. Numerical method using differential equation. Numerical method using differential equation. Finite difference method, FDM. Numerical method using differential equation. Plastic analysis method. Plastic analysis method used for steel design and collapse load calculation. Used for steel design and collapse load calculation. Types upper bound theorem. Types upper bound theorem. Lower bound theorem. Lower bound theorem. Plastic hinge method. Plastic hinge method. Number 4, quick summary table. Quick summary table. Category, method, best for. Category, method, best for. Category. Determinant. Method of joints, best for trusses. Method of joints, best for trusses. Method of section, trusses specific members. Trusses specific member. Basic equilibrium. Basic beam simple frames. Basic equilibrium method, best for beam simple frames. Force method, category force method. Consistent deformation, best for redundant beams and frame. Redundant beams and frame. Castigliano, best for redundant structure deflection. Unit load deflection. Displacement method. Slope deflection. Best for continuous beam frames. Method, moment distribution. Best for manual analysis of rigid frame. Method, stiffness matrix. Best for computer-based large structure. Modern method. Category modern method. FEM. Best for complex 2D plus 3D structure. Method FEM, best for complex 2D plus 3D structure. Method, modern method. Plastic analysis. Best for steel structures at collapse. Want node diagram or PPT. I can prepare structural analysis note 10 to 15 page. Structural analysis notes 10 to 15 pages. Full PPT or teaching. Solved example beam frame trusses. Solved Example, beam frame trusses. Comparison charts between methods. Comparison charts between methods. Just tell me what format you need. The method of structural analysis are techniques used to determine the reaction internal forces like axial force, shear force, and bending moment, and displacement, deflection, and rotation of a structure under various loads. The method the methods of structural analysis are techniques used to determine the reaction internal forces like axial loads, axial force, shear force, and bending moment, and displacement, deflection, and rotation of a structure under various loads. These methods are broadly categorized based on the type of structure they analyze, statistically determinate or indeterminate, and the approach taken, force or displacement. These methods are broadly categorized based on the type of structure they analyze, statistically determinate or indeterminate, and the approach taken, force or displacement. Number one, classification by structure type. Classification by structure type. Statistically determinate structure. Statistically determinate structure. These structures can be fully analyzed using only the basic equation or static equilibrium. Sum fx equal to O, sum f y equal to O, sum m equal to OS. Statistically determinate structure. These structures can be fully analyzed using only the basic equation of static equilibrium. Sum fx equal to OS, sum f equal to y equal to OS, sum m equal to OS. Examples of method, method of joints and method of section for trusses. Method of joints and method of section for trusses. Statistically indeterminate structure. Statistically indeterminate structure. Statistically indeterminate structure. These structures have more unknown forces, reactions, or internal forces than the available static equilibrium equation. Therefore, they require additional equation based on the structure compatibility, maintaining continuity and no breaks, and the material force displacement relationship. Examples of method, force method and displacement method. Statistically indeterminate structure. These structures have more unknown forces, reactions, or internal forces than the available static equilibrium equation. Therefore, they require additional equations based on the structure compatibility, maintaining continuity and no breaks, and the materials force displacement relationship. Examples of method, force method and displacement method. Number two, primary method for indeterminate structure. Primary method for indeterminate structure. The most fundamental approaches for indeterminate structures are the force method and the displacement method. The most fundamental approaches for indeterminate structures are the force method and the displacement method. Features: force method, flexibility method, displacement method, stiffness method. Features: force method, flexibility method, displacement method, stiffness method. Primary unknowns, force or moment considered redundant to make the structure determinate. Forces or moment considered redundant to make the structure determinate. Displacement, rotation and translation at joint. Displacement, rotation and translations at joints. Covering equation, compatibility equation based on displacement, compatibility equation based on displacement, equilibrium equation based on forces moment, equilibrium equation based on forces moment. Matrix form. Flexibility matrix relates force to displacement. Flexibility matrix relates force to displacement. Stiffness matrix relates displacement to force. Stiffness matrix relates displacement to forces. Features: force method, flexibility method, displacement method, stiffness method. Sustainability, structures with a low degree of static indeterminacy. Structures with a low degree of static indeterminacy. Displacement method, stiffness method. Structures with a high degree of static indeterminacy, better for computer analysis. Structures with a high degree of static indeterminacy, better for computer analysis. A force method, compatibility method. A force method, compatibility method. These methods are redundant forces as the primary unknowns and rely on satisfying the compatibility conditions of the structure. These methods used redundant forces as the primary unknowns and rely on satisfying the compatibility conditions of the structure. Method of consistent deformation. Method of consistent deformation. Theorem of least work. Flexibility matrix method. B displacement method. Equilibrium method. These methods use joint displacement as the primary unknown and rely on satisfying the equilibrium equations of the fluid structure. They are generally preferred for computer-based analysis. These methods used joint displacements as the primary unknown and rely on satisfying the equilibrium equations of the structure. They are generally preferred for computer-based analysis. Slope deflection method use the relationship between moments in rotation and relative deflection to set up equilibrium equation at the joint. Slope deflection method use the relationship between moments and rotation. Slope deflection method use the relationship between moments in rotation and relative deflection to set up equilibrium equation at the joints. Moment distribution method. Hardy cross method, and iterative method suitable for hand calculations of continuous beams and frame. And iterative method suitable for hand calculations of continuous beams and frame. Stiffness matrix method, the backbone of modern computer analysis, where the structure behavior is modeled using a system of linear equations involving the structure's stiffness. The backbone of modern computer analysis, where the structure's behavior is modeled using a system of linear equations involving the structure's stiffness. Number three, advanced and numerical method. These methods are powerful for handling complex structure, material, and loading conditions, and are almost always solved using computer software. These methods are powerful for handling complex structure, materials, and loading conditions, and are almost always solved using computer software. Finite Element Method, FEM, FEM, a numerical technique that divides the structure into a large number of smaller interconnected elements, finite elements. This allows for very detailed and accurate analysis of complex geometric state distribution and non-linear behavior. That means in solid mechanics, dynamic and heat transfer. Finite Element Method, FEM, a numerical technique that divides the structure into a large number of smaller interconnected elements, finite elements. This allows for very detailed and accurate analysis of complex geometrics, stress distribution, and non-linear behavior. E.g., that means in solid mechanics, dynamics, and heat transfer. Virtual work method, energy method. That means Castich-Liano theorem. Castich-Liano's theorem. Principles based on the conservation of energy, work, and strain energy used to calculate. Virtual work method, energy method, that means Castich-Liano's theory, principles based on the conservation of energy. Principles based on the conservation of energy, work and strain energy used to calculate. Displacement or solve for redundant forces in both determinate and indeterminate structure. Displacements or solve for redundant forces in both determinate and indeterminate structure. Approximate method, simplified techniques like the portal method or cantilever method used for a quick preliminary analysis of multi-story frames before detailed design. Approximate method, simplified techniques like the portal method or cantilever method used for a quick preliminary analysis of multi-story frames before detailed design. Would you like a more detailed explanation of a specific method such as a moment distribution method or the finite element method. Would you like a more detailed explanation of a specific method, such as the moment distribution method, or the finite element method? Now I finished my video. Next day I discussed another chapter of civil engineering, project and plan related execution item. All are requested, if you are like my video, please subscribe my channel. All are requested, if you are like my video, please subscribe my channel. সবাইকে একটাই রিকোয়েস্ট করছি, ভিডিওগুলো স্কিপ করবেন না, স্ক্রল করবেন না, পুরো ভিডিও দেখবেন, দেখলে অনেক কিছু জানতে পারবেন এবং শিখতে পারবেন। এবং বেশি বেশি সংখ্যায় শেয়ার করবেন, যাতে বেশি সংখ্যক ভিউয়ার্স এই ভিডিওগুলো থেকে উপকৃত হয়। চ্যানেলটিকে ভালোবাসা দেবেন, ভিডিওগুলোকে লাইক করবেন, হাইপ করবেন এবং সাবস্ক্রাইব করবেন। চ্যানেলটিকে ভালোবাসা দেবেন, ভিডিওগুলোকে লাইক করবেন, হাইপ করবেন এবং সাবস্ক্রাইব করবেন। ওকে, থ্যাংক ইউ, বাই।